are all well aware of these maintenance strategies which are presently used in industries. First is the breakdown maintenance. In breakdown maintenance, what people will do, they will allow machine to break down. Afterwards, they will carry out the maintenance activities. It is just like a firefighting situation. Okay. So one step ahead of this breakdown maintenance is the preventive maintenance. In preventive maintenance, what maintenance people will do, so they will carry out maintenance action based on the past histories, experience and manufacturer's recommendations. For example, machine tool manufacturers has recommended to change the machine tool bearing after 1 year. Maintenance people, they don't want to take chance, they will simply change it. Even though bearing condition may be good, but they don't want to take chance, but they will simply replace it. So in order to overcome this, predictive maintenance has evolved. It is in this method, what people will do, they will look for early signs of failures. Okay, it is not going to prevent the failure, but only thing is that in predictive maintenance, people will predict the health condition of the machines by using various parameters well in advance, so that they can plan the maintenance activities. This is also called CBM, condition based maintenance, because whatever the maintenance activities you are going to carry out, it is based on some results. Okay, and one step ahead of this is the proactive maintenance. In proactive maintenance, what people will do, it is very effective for oil lubricated system like gearboxes, oil lubricated bearings. Here what people will do, they don't allow system to fail, means they will not allow initiation of the failure itself. It is just like monitoring your blood level. If blood has got some problem, then doctors will prescribe some medicines so that you can they can maintain the health condition of the blood itself. Similar to that for machine tools. So here they will maintain the oil condition. Is there any moisture? They will try to remove it. Is there any contamination, wear debris and other things? They will try to remove it, so that they can maintain the machine health condition, so that initiation of the failure itself is avoided. Okay. So this is the staircase for TPM. Nowadays TPM is very widely discussed. All industries, they wanted to adopt TPM, they wanted to implement TPM. If you want to achieve this TPM, you have to go through these stages. In condition based maintenance, so it is a cycle of actions. We have to measure, for example, vibration, analyze the data, plan for the action, maintenance action, and then implement the maintenance action. Once you implement the maintenance action, most of the times there will be some minor problems will be there. So that has to be checked once again, and it has to be corrected, and again this cycle continues. So monitoring of conditions should be the central basis for maintenance activities, not based on some manufacturer recommendation or past history or experience. It should be the whatever the maintenance activities we are going to carry out, it should be based on the machine condition. So what are all the parameters we can use for condition monitoring? We can use wear debris, which is very useful if you are using oil lubricated bearings, gearboxes, wherever you are using oil. Okay, and noise also you can use it, but only thing is it is a bit complex. For example, in a workshop you will be having n number of machines. Suppose if you measure the noise, it will capture the noise emitted by all the machines, then analysis it becomes very difficult to analyze. So temperature, movement or clearance change, you can use it. This technique is very widely used in large machines like turbines, hydrostatic machines, hydrodynamic bearings, wherever it is there, they will use it to monitor the gap between the stationary part and the moving part. Whenever it becomes very close to the stationary parts, automatically machine will trip off. Okay, temperature. So we can use temperature also for monitoring the health condition of the machine. Nowadays thermography is quite popular, and vibration, it is scientifically proven. We will discuss why we are going to use vibration in the coming slides. Oil properties and the parameters. Okay, for proactive maintenance this is a must, and motor current if you are using electrical machines. Okay. So now we are coming to the core topic, that is a predictive maintenance of rotating machineries through vibration monitoring. So in this we will discuss what is the basis, how to implement, how to take decisions and benefits of this activity. See, most of the failures in the rotating machines are due to damaged bearings. Bearing will get damaged over a period of time due to usage, and then gears fault, vanes of impellers on the shaft, and assembly faults like unbalance, misalignment, bent shaft, even oil will in case of hydrostatic and the hydrodynamic bearings. All these factors, what it does, it will affect the vibration emitted from the machines. Okay, so various mechanical faults can be detected by making simple vibration measurement. Okay, therefore nowadays people are using vibration as a very good measurement parameter in order to predict the health condition of the machines. See, typically the machine will fail, 30% of the machine will fail due to product faults. Okay, and 37.5% of the machines will fail due to mishandling. If the machines are not maintained properly, operated properly, so then it will fail. Due to actually usage, only 28.5% of the machines will fail. Okay, from this you can make it out that because of other reasons only machines are failing, not because of the actual usage. Okay, so by measuring the vibration, you will come to know all these faults. Okay, what is the problem? Then you can rectify the problem in the initial stage itself. Otherwise, what happens? It will lead into cascading effect. Instead of changing the simple bearing, you have to replace the entire spindle itself. Okay. So it doesn't mean that new machines will always give less vibration. Sometimes it may give more vibration also. It is because of these reasons. Abuse before or during installation, if the installation is not proper, then also we will get higher vibration. Improper installation and assembly is not correct. Improper, there is assembly errors, then also new machines will also generate higher vibrations. Inadequate and improper lubrication, if the foundation is not proper, then also we will get higher vibrations. Okay, it doesn't mean that new machines will always give less vibration. Okay, it is influenced by these parameters. So this is, as the time progresses, we are using the machine, naturally vibration level will increase due to wear and tear, okay, which may be caused because of contaminants that might have gone inside the bearing, okay, and then corrosion induced by moisture, oxidation, and then electric current leakage. Sometimes material defect will be there and manufacturing defects will be there. All these things leads to higher vibration. Okay. Now we are coming to vibration monitoring. By using vibration monitoring, what are all the faults we can identify? By using vibration, we can identify unbalance. In unbalance itself, there are various types. Static unbalance is there, couple is there, dynamic unbalance. Okay. Misalignment between the two meeting parts. It may be angular, parallel, or combination of these two. Eccentric rotor, bent shaft, mechanical looseness, even structural weakness, soft foot if the machine is not mounted properly, resonance, this is one of the very important phenomena, and beat vibration if two machines are running at very close to each other at the almost same speed or maybe difference of 1 or 2 hertz, and mechanical rubbing and problems of belt driven machines. In case we can find out by using vibration journal bearing defects also, anti-friction bearing defects. By using vibration monitoring, we can pinpoint whether the inner race is having a problem, outer race or cage, even the ball. To that extent, we can use vibration monitoring. And the problems related to hydrodynamic and aerodynamic machines, okay, gear problems, electrical problems of AC/DC motor. If you see, almost 98% of the problem what we are noticed in the machine tools, all the defects can be identified or detected by using the vibration monitoring. Suppose we want to implement the condition monitoring of machines for predictive maintenance. Okay, how to go about? First, we have to select the machine depending upon the critical from the production point of view. These are all called bottleneck machines. Nowadays, everywhere cost reduction is there. We cannot have duplication of machineries. That means we are going to have one more plant. Okay, that is not allowed. So suppose if this machine breaks down, whole production stops. So we have to include this type of machines for this program. Critical from the maintenance point of view, nowadays we are using a lot of imported machines. It takes some time for us to import spare parts from abroad. Sometimes we have to import even skilled laborers also to carry out maintenance activities, and it takes a lot of time and effort. These type of machines can be included in predictive maintenance program. Critical from the product quality point of view. Okay, suppose your bearing is damaged, it will affect your surface finish. Whatever the components you are going to produce, all the components will get rejected in the quality inspections. So this type of wherever precision accuracy is required and surface finish is required, we can include those machines also. And also from the safety point of view, sometimes what happens if the machine fails all of a sudden, it will lead into accidents. So those type of machines can be considered for these programs. And availability of spares and skilled labors, this we have discussed. And whatever the machine we are going to include in the predictive maintenance, it should respond to the vibrations. Okay. So next is the where to measure. Okay, we have selected the machine. Next thing is that where to collect the vibration data. Preferred locations are the bearing housing, because whatever the reactions are there, it will act on the supports. The supports are nothing but the bearings. So we have to collect the vibration data very close to the bearing housing. Is there any accessibility problem? We can go as close as possible, and we can collect the vibration data in X, Y, Z direction, horizontal, vertical, and the axial direction. It depends upon the what type of machines. For spindle, you can collect only one direction data, that is the radial vibration, either horizontal or vertical. In case of coupled system, we have to collect the axial vibration also, because axial vibration will give you the coupling problems, alignment problems. Okay, and we have to use proper notation for identification of the measurement points. For example, if you are measuring the horizontal direction, you can use H for that, that indicates horizontal, V for vertical. This is only for identification. So we have to identify each measurement location by number or name, etc., to avoid error in the data collection. And also wherever the measurement points are there, we have to mark with some paint, so that next time also we will collect the vibration data at the same location. Otherwise what happens, if we collect at some other location, we cannot able to correlate the vibration data, and we cannot able to interpret the vibration data. These are all the things we have to take care. So during the analysis, this is very, very important. We have to collect all the machine specific details, like operating speed, what is the operating speed, and then operating conditions. So normally condition monitoring of machines, people will prefer no load condition, that is called the ideal condition. If some machines you cannot run at no load, it will be running at some percentage of load, that we have to note down. Next time also we have to ask operator to set the same load, and we have to collect the vibration data. And machine train data or the kinematic data, like what type of bearings, okay, and the bearing geometry, number of balls, outer race ID, inner race ID, and number of shafts, if it is a gearbox, gear type, what type of gears they are using, spur gear, helical gear, all those things, number of teeth on each gear. If we are using centrifugal pumps and other things, fluid handling pumps, we have to collect number of vanes of impellers and drawings, etc. So we have to document all the measurement conditions before going for the data collection. So for example, if you see machine number 1136, it will operate at a spindle speed of 900 rpm. Suppose if it is running at some other speed, we can ask the operator to run at that particular speed, and we can collect the vibration data. This is the measurement chart. Sometimes what happens nowadays, we are using machining centers, it will have n number of tools. So we have to identify some tool which is having less imbalance, like a dummy tool. We can ask dummy tool to for the vibration measurement. With that dummy tool, we have to collect the vibration data. Suppose if you are changing the tool, so even vibration values, everything will vary, because a different tool will have different unbalanced level and other things. Okay. So next comes which parameter we have to use for predictive maintenance. Suppose we are doing a vibration monitoring. You know very well that you can measure vibration in terms of acceleration, velocity and displacement. Displacement is recommended less than 100 Hz frequencies. Velocity we can use it from 10 Hz to 10 kilohertz. Acceleration we can use it from 1 Hz to 50 Hz. Only thing is that we have to select a parameter which gives flat response over a wide frequency range. That is a must. So that's what it is described here. Nowadays people are using displacement measurement for shaft vibrations. Okay. Normally in predictive maintenance velocity is used. Okay. So here you can see here displacement at low frequency it gives flat response. If you see the velocity at medium frequencies it gives very flat response, and acceleration at high frequencies it gives flat response. Okay. So different next comes what type of sensors we have to use. Different types of sensors are available. For shaft vibration measurement you can go for displacement probes. In displacement probe itself you can have inductive probe, capacitance probe, eddy current probes. Okay. So only thing is that it has got limited frequency range and dynamic. You can use it from 10 Hz to 1000 Hz. Okay. Next is the velocity transducer. Earlier people were using this transducer. Because of some drawbacks nowadays people are not using, because it is quite bulky and it is having a limited frequency range of from 10 Hz to 1000 Hz. So nowadays people are not using this. Nowadays people are using accelerometers. It is most widely used nowadays because it is available in various sensitivities and dynamic range. Even weight is also less. Okay. And it is having a very high dynamic range as well as the frequency range. It is available with ICT type also. You need not to use any amplifier to convert the charge into voltage and other thing. Directly you can connect it to the analyzer and you start collecting the vibration data. So, and it doesn't require any power supply. It is a self-generating type. If you are using ICP, you have to supply 4 milliamps of current to make it operative. Okay. Next comes how to mount the sensor on the machine tools. Different mounting techniques are available. This is very, very important. The preferred technique is stud mounted, because if you use handheld and other things, no, this useful frequency range will come down. Even though your accelerometer is capable of measuring 10 kilohertz frequency range, because if you are using improper mounting techniques, if you hold same sensor with a hand, that useful frequency range will come down to 1 kilohertz also. Okay. You think that you are making measurement up to 5 kilohertz. Because of this improper mounting technique, your sensor is not measuring above 1 kilohertz itself. Okay, we have to use proper mounting technique. The stud mounted is preferred. Okay, so that we can make use of entire useful frequency range of the accelerometer. Okay, this is the typical instrumentation system for vibration monitoring. Here we have taken the example of the lathe. The accelerometer is mounted on the spindle housing. Earlier, our people were using only a vibration meter. It gives only the overall vibration level. From that, we cannot conclude what is the problem in the machine. Okay, 5 millimeter per second of vibration we have measured. We don't know that is because of what reasons. So next comes level recorder and other thing. Afterwards, things are advanced, and now we are using FFT analyzer and PC-based data management systems. Okay, different analyzers are available in the market for vibration data collection and measurement. Now, various monitoring techniques and their application we will discuss. Overall vibration trending. You can use overall vibration trending also. It is a coarse indicator of the machine condition. It is not going to give you a 100% health condition of the machines. Okay, it is having a drawbacks that we will discuss in the coming slides. And for bearing damage or bearing faults, we can use shock pulse, kurtosis, spike energy. Earlier people were using this. Nowadays we are not using this. We are going for envelope detection. It is also called amplitude demodulation technique. And then comprehensive spectral trending. Why we are going for comprehensive spectral trending means you can detect various faults, what we have discussed in the initial slides. We can find out all the faults in the comprehensive spectral evaluation or spectral analysis. So one thing is that vibration will not generate on its own. It needs some excitation forces. If there is a excitation forces, then only vibration will appear, otherwise vibration won't occur. So the causes for these excitation forces are machine faults like unbalance, misalignment, looseness, bearing faults, oil well, even gear mesh, all those things. Okay, this will lead into this type of vibration like periodic vibration, impulse, or random type of vibration. So these forces will act on the bearings. Okay, the bearings has got a bearing housing that is called the transmission path. So that transmission path will respond to this excitation forces. There we call it as a machine dynamics comes into picture. Okay, whatever the vibration we are measuring at the housing is the response of the transmission path to the excitation forces. That is the modified one. So whatever the output we are getting, we can measure in terms of RMS velocity, peak acceleration, and then crest factor, kurtosis, all those things. Those are all old methods. Nowadays we are going for spectral evaluation. In this you can find out low frequency faults like unbalance, misalignment, looseness, even medium to high frequency faults like bearing defects, gear mesh, all those things. Okay, so we recommend to go for spectral evaluation method for predictive maintenance. Okay, so now we are coming to why overall vibration trending. Why we are not using this overall vibration trending? It will give you only the overall condition of the machine. No diagnosis is not possible. We cannot do any diagnosis or interpretation or analysis. Okay, if there is a drastic change in the vibration, then only overall vibration level will change. If there is a minor change, it won't reflect in the overall vibration level. Most of the time what happens, vibration level will be, overall vibration level will be same. All of a sudden machine will fail because bearing defects and other things, it will generate very small amount of vibration during the initial stages. Okay, so it can be used for general purpose, like if you want to meet some standards, ISO standards and other thing, if you want to fulfill the criteria mentioned in those standards, you can use the overall vibration. Otherwise, if you are doing predictive maintenance through vibration monitoring, we recommend you to go for spectral trending. So next technique is the envelope detection. It is very useful if you want to find out the bearing defect faults. What happens if you are measuring the vibration, you are measuring low frequency as well as the high frequency components. These bearing defects are of low amplitude and the high frequency components. These frequency components are masked by the high amplitude and the low frequency components. So what we have to do, we have to filter out this low frequency and the high amplitude signals from the signal so that we will get the bearing related false frequencies. So that's what it does. Envelope detection means it does amplitude demodulation. They will use high pass filter, they will pass the signal through the high pass filter, they will extract only the bearing defects and the gear faults related frequencies. Once you do the amplitude demodulation, you will get the envelope spectrum where bearing faults related frequencies will be enhanced in this spectrum. Otherwise, you don't see this bearing defect frequencies in the normal spectrum. Okay. So CMT has developed this vibration data manager for data collection and analysis and the data management. So in this you can select machine number and the machine name and the measurement locations. The moment you select, it will give you the base signature or the base vibration reading for that particular measurement locations, and it will give you the measurement conditions also, what condition you have to collect the data. Once you collect and append it, so you will get all the values will get appended. And also, for example, if you see here, so in condition monitoring we will give you the advance warning like prepare for bearing change, because it takes some time for maintenance people to procure the bearings also. So we have to give some lead time, at least 2 to 3 months. The moment they finish off all these activities, they can go for the bearing replacement. You can see here in the last row, the vibration level has increased drastically when compared to base signature, that is first row. So then further we cannot allow this machine to, this bearing to run, otherwise it will affect the component quality. Then we have to recommend them for go for bearing change. So the moment the bearing is ready in their store, they can plan this bearing replacement in some holidays or shift changeovers, all those things. They can replace it so that they can bring back the machine back to the original conditions. Okay. So this is how your vibration trend chart will look like that, looks inside the data management. So Next thing is that is there any guidelines for making the decisions? Of course, you can use ISO standard like 2372. So if you want to fulfill some criteria, here machines are divided into power rating like 15 kilowatts, 15 to 75, and my large machines which is mounted on rigid foundation. So good means, for example, 15 kilowatt, good means 0.71 millimeter per second of vibration you can allow. Okay. In this, it is not going to specify whether what type of machines and other things. If you are using a very precision grinding machines, even 0.771 millimeter per second itself is a abnormal vibrations. So that they are not mentioned. These are all the drawbacks of this standards. So one more standard you can use ISO 10816. Here they are divided machines into different classes based on the same power rating. You can use this only for fulfilling the standards. Based on this, you cannot take any actions. This is very useful when you are making data interpretation or data analysis. If unbalance is there, normally it will occur 1 into RPM. So misalignment, normally it will occur at 2 into RPM. And bearing defect frequencies, these formulas are there. Based on this formula, you find out what is the bearing defect frequencies, and you look for the same frequency components in the vibration spectrum. If it matches, then you can conclude that this is because of outer race, inner race. And journal bearing, if it is loose, it will normally occur at subharmonic, less than 50% of the 1 into RPM, you will notice it. So even mechanical looseness, it will normally occur at 2 into RPM in radial direction. So like this, you can find out even electrical induced vibrations also. We can use vibration for this purpose also. So based on this analysis, you can make a report, you can give it to your maintenance department, so that with your remarks what to do, like prepare for bearing change or change bearings. If unbalance is there, you can ask them to balance it so that vibration level will come back. See, normally what happens in normal industry, if there is a higher vibration and the noise level, they will always suspect bearing. Simply they will replace the bearing. It may not be bearing problem, it may be some other XYZ reasons. So if you use this condition monitoring technique, you can take care of this type of errors. So here few case studies are there. This is an unbalanced case study. So this is 110 HP 10 HP air tube blower. It was having very high amount of vibrations. So one of our customer, he has called for investigation. So we went there. Then we found that it is because of imbalance. So we did balancing exercises. Then afterwards, you can see the vibration level. It has come down to 4 millimeter per second. So what I am trying to say is that even 29 millimeter per second, some people they may suspect that bearing is faulty. It is not always. It is because of unbalance. If you take care of unbalance, vibration level will come down, so that you can bring back your system back to the original condition. This is the typical bearing case study. The blue color, it indicates the base signature. For condition monitoring of machines, most important thing is the base signature. When the machine is new, please collect the base signature and preserve it. So it is very useful for future comparison. Suppose once you replace the bearing, that signature will go off and a new signature will come, because each bearing will have different signatures. Okay. So pink color indicates prepare for bearing change. You can see there is a drastic deterioration in the machine bearing condition because of usage. So you can see further after 3 months, the red color one, vibration level has increased at the low frequencies, because after sometimes what happens, bearing will become loose. So low frequency components will appear at the low frequency region. Then afterwards they are replaced the bearing. You can see the green color one, it has come back to original condition, because here that both the spectrum will not match, because each bearing will have different signature. So this green color will become the new base for the future comparison. Okay. So this is a typical gearbox case study. So we are doing this condition monitoring for Ballarpur paper mills. It is there in Maharashtra. So you can see here, this is the gearbox signature, green color one, it is very good. Then after 1 year of time, some gear pair, it started having problem, that is indicated by the red color one. So we have suggested them to replace only that particular gear, not the entire gearbox. Okay. So this is again, I will complete. So, okay. See, these are all the benefits of doing condition monitoring. CMT is doing these activities since from 1983. So we have collected some data from 1985 to 1990. You can see here earlier they were replacing 49 spindles. After implementation of the condition monitoring, they replaced only 11 spindles. Okay. Even in electrical motors, earlier they were replacing 43 motors. Okay. After implementation of this condition monitoring or predictive maintenance program, they are replaced hardly 6 motors. In hydraulic power pack, they are replaced only 1 out of 23. Okay. So what are the benefits of condition monitoring? Machines will be available continuously for the productions. Okay. There is no machine downtime. Whatever the intervention is there, it is based on the forewarning, based on the analysis results. Maintenance people, they know what they are supposed to do. Okay, you can plan this maintenance activities in some holidays so that productions is not affected, and you can control inventory also. You need not keep inventory also if you are having effective condition monitoring program. Okay, because bearings are very costly. So this is what CMT has provided this condition monitoring services to various industries in the past. Okay, so we have the state-of-the-art facilities at our organization. So this is our services. So we conduct training programs. We take noise and vibration customized projects, environmental noise, sound power measurement as per national and international standards, all those things. So this is one of the projects we have executed recently for Indian Railways. Now Indian Railways, they wanted to reduce the noise in their locomotives. So they are requested CMTA to help in this regard. So we did sound intensity mapping, noise mapping. We did comprehensive noise analysis. Based on our analysis, now they are implemented a lot of changes in the locomotives. In future, you will see a lot of changes in the diesel locomotives. Okay, because a lot of people, they are complaining about the noises emitted by this diesel locomotive, because a lot of people, they are staying very close to the railway track and other things. So now Indian Railway is taken seriously, and they are working on that. We are working with them. Okay. So this is a tractor. We have worked with automobile people also, wherever noise and vibration problems are there. And we work with some cigarette making machines also. So there also noise is a major problems. They wanted to control the noise also there. So, and we are working with a lot of defense people, because in the Navy and other things, vibration and noise is very, very important. They wanted to control the noise and the vibration, because mill standards are very stringent. So we have worked with this composite beds. Nowadays, people are giving more and more emphasis on composite beds, because they can take care of higher dynamic loads. Okay. So we have worked with metro people for ground vibration measurement. So, okay, thank you.